Math 3, Unit 8, Whiteboard Review. The first problem we have here, it's going to be a true and false question, and they've given you this information, and we need to solve for x. Because of our trig functions, sine, cosine, tangent, there are multiple ways of solving for x. And if you look over here, they have sine, cosine, tangent, all these different ways. So the easiest thing to do, and all of them are based on the angle of 63, is to find the sine, cosine, and tangent for all of the sides and see which ones make true and false statements. So we know that sine is opposite over hypotenuse. We have our SOHCAHTOA. So sine of 63, opposite is x, over hypotenuse is 15. And if I solve for this here, I would multiply both sides by 15 in order to get x by itself. And we get x equals 15 times sine of 63. Okay, so that's one answer. We're going to go ahead and do cosine next. So for cosine of 63, it is adjacent, which is 7, over hypotenuse, which is 15. There is no x in here. So therefore, x can't equal anything in this problem because there isn't an x to solve for with cosine. So any cosine answer over here is automatically a false because there is no x within the cosine function there. And then last we have tangent of 63. And tangent is opposite over adjacent, x over 7. To solve to x by itself, we would multiply by 7 to both sides. And so x equals 7 times tangent of 63. So now we work through here. On here, this says 7 sine of 63. Well, the answer we have is 15 sine of 63, so this would be false. Here, x equals 7 tangent of 63, and that is what we have here, so that's a true statement. Here we have 15 sine of 63, which is what we have, so true. And this says tangent of 63 divided by 7. Well, 7 times tangent of 63 is a lot different than tangent of 63 divided by 7, so that is also false. In order to find two positive coterminal angles, remember coterminal means that it's going to loop around another 360 degrees. It means that it terminates or ends at the exact same point. If you're looking at it visually, 220 degrees is right here. Okay, and so a coterminal angle is just starting here and going a whole 360 around again. And so in order to get another positive coterminal angle, we will add an additional 360 degrees to that. When we do that, we end up with 580. So 580 degrees is an additional positive coterminal angle. I can get another positive coterminal angle, and again, they asked for 2 here. So all I do is take the 580 degrees, add another 360, because we just do another loop around. We add, and I end up with 940 degrees. Those are my 2 positive coterminal angles. 2 negative coterminal angles is we're trying to get negative values. So we're subtracting 360. We are going clockwise instead of counterclockwise. And so we're going to take 220 and we're going to subtract 360. Well, it's easier to have the larger number on top, so I'm going to put negative 360 and we have a positive 220. I'm going to subtract and I get negative 140 degrees. Since I need 2 negative coterminal angles, I would just take my negative 140 degrees and I'm going to subtract another 360 degrees. Well, now I have 2 negative numbers, so I add them together. That's 0, carry the 1. We end up getting negative 500 degrees. So my 2 negative coterminal angles are negative 140 degrees and negative 500 degrees. Number 4, it says if the terminating ray for theta is in quadrant 3, so if I were drawing a picture here, the terminating ray is in quadrant 3, which is down here. It says then the given statements is true or false. Okay, So if we're looking here, this is saying cosine is greater than 0, which means that cosine would be positive. Here, cosine is less than 0, which means it would be negative. And so if we look in this third quadrant, okay, our x's or cosines are going to be negative or positive. And in this quadrant, our x's, our cosines, are negative, okay, because it's going left. In this quadrant, you go left on the x-axis, which is negative. Our y's, or our sine values, so sine is going on the y-axis. To get in quadrant 3, we'd have to go down. So our sine values are also negative. Our tangent, which is y over x, means you would have a negative divided by a negative, which actually equals a positive. So here in quadrant 3, is cosine positive? Nope, it's negative, so this statement is false. Here, cosine less than 0, that's negative values, that is true. Sine is greater than 0, that means sine is positive. Is sine positive? Nope, sine is negative, false. Sine is less than 0, which means sine is negative, and that is true. Tangent is greater than 0 would be positive values, and that is true. Tangent is less than 0, which means it's negative values, and that would be false. Next, it states to find the solution for x. And so this is kind of similar to number 1 that we did back there, but this time we're trying to find the degree. Okay, and if you look here, we have tangent, cosine, and sine. And so for our SOHCAHTOA, if I'm doing sine for here, so that means sine of x equals opposite, which is 15, over hypotenuse, which is 17. When you are finding the angle, we do the inverse function. And so this is really what you would do to find the inverse function is you would take sine to the -1 of 15 over 17 equals x. And so for my sine function, if you look, that does match up, so this one is true. Okay, so for cosine now, cosine of x equals adjacent, which is 8 over 17. For cosine, it would be cosine to the -1 for finding the inverse of 8 over 17 equals x. On this cosine, it has 15 over 17, which is not true. That would be false. For tangent, tangent of x equals opposite, which is 15, over adjacent, which is 8. And so for finding the degree, we take tangent to the -1 of 15 over 8 equals x. And when we look, that matches what we have there, so that is true. Next, find the reference angle for 150 degrees. If we were to draw this, if we look at our coordinate plane, this is 0 degrees and 360 degrees. Over here, it's 180. Half 180 up here is 90 degrees, and here at the bottom is 270 degrees. So 150 degrees is in between 90 and 180. So we draw this. This would be 150 degrees. And your reference angle, it always goes to the x-axis. It is always positive, and it's always less than 90 degrees. And so 150 to 180, this little angle right here, the reference angle is 30 degrees. You can also just find that by taking 180 minus 150, and you end up getting your 30 degrees. When you're finding the reference angle in radians, you will still set up your coordinate plane. We know that 0 is 0, and then when you're going to find the whole circle would be 2 pi. So we double whatever our denominator is, and I'm choosing 12 as my denominator because that's there. So 2 pi would be double 12, which is 24 pi. 1 pi over here would be 12 pi over 12. And then we take half of 12, which is 6 pi over 12. And then we add that, and we add another 6, and 12 plus 6 is 18 pi over 12. And so our 17 pi over 12, when we're drawing that, would end up in quadrant 3. This is 17 pi over 12. And again, our reference angle always goes to the x-axis. Okay, it is always less than 90 degrees and always positive. And so my reference angle, which is that little piece here, we're trying to figure out from 12 pi to 17 pi, what is that distance? And so 17 minus 12 is 5. So we get 5 pi over 12. My reference angle there is 5 pi over 12. Number 8, it says solve for theta such that it's between 0 and 360 degrees. So sine, here sine is positive. So we know that sine is dealing with y. Y is positive in quadrants 1 and 2. Okay, so quadrants 1 and quadrant 2. So we are looking for a y value that is root 3 over 2 in both quadrants 1 and 2. So when we go here, in quadrant 1, okay, root 3 over 2 is, we're trying to find our y value, sorry. Root 3 over 2 y value is right here, and that is at 60 degrees. In quadrant 2, our y value, root 3 over 2, is 120 degrees. So we have 60 degrees and 120 degrees. Okay, number 9. We are converting to degrees and to radians. When you are converting from radians to degrees, you are multiplying by 180 over pi. We are trying to eliminate pi, okay? When you're changing degrees into radians, you are multiplying by pi over 180. You want the pi to end up being on top. So it's either going to be 180 over pi or pi over 180, depending on what you need. And then you can just reduce. So here I can reduce, both the pi's cancel out. 12 goes into 180 15 times. Oops, 15 times. And 5 times 15 is 75. So 5 pi over 12 is the same thing as 75 degrees. Over here we reduce, and 5 goes into both 125 and 180, and so we reduce. This becomes 25. 5 goes into 180 36 times. You multiply tops with tops, bottoms with bottoms, and we end up with 25 pi over 36. And that is the answer for our radians. Okay, moving on, number 10. Sketch the angle in standard position and find the information they have over here. So we're dealing with a negative pi over 4. So we would still mark our positions on here and dealing with a denominator of 4. And so if this is 4, then we have 8 pi on top, because we would double that. Over here we have 4 pi over 4. But because we're dealing with negatives, I'm going to end up making both of these negatives, which instead of when I divide this by 2, I get 2 pi over 4. Instead of putting 2 pi over 4 on top, I'm going to put negative 2 pi over 4 on the bottom. And then as we'd go around, this would end up being the negative 6 pi over 4 up here on top. Negative 1 pi over 4 ends up being here in quadrant 4. Okay, and we know that this is negative 8 pi over 4 when you get to 360 or when you do the 2 pi, but we also know this is at 0 as well. Okay, and so from here, this was our angle, so we sketched the angle, and in order to find the reference angle, we go up to the x-axis, and we know it's always positive, and the reference angle is ending up being the same thing as the angle we drew, and the distance from here up to 0 is still just pi over 4. So our reference angle is pi over 4, and remember that our reference angles are always positive. Now they want a positive coterminal angle. So in order to get a positive coterminal angle, we would need to wrap this around another 360 degrees. But in terms of radians, you are adding 2 pi. And in this case, we know that 2 pi is 8 pi over 4 if we're keeping a common denominator. So for my positive coterminal angle, we take negative pi over 4 and we add our 2 pi, which with a common denominator is 8 pi over 4. When you add that together, we end up with 7 pi over 4. So my coterminal angle is 7 pi over 4. Our negative coterminal angle, we would just subtract the 8 pi over 4. So negative pi over 4, and I subtract an 8 pi over 4, and we end up with a negative 9 pi over 4 is a negative coterminal angle. Now we're dealing with degrees. We have 410 degrees. Again, if we're marking up our unit circle here, this is 0 and 360. 180 is on the left side, 90 is at the top, 270 is at the bottom. 410 degrees is going to wrap all the way around at least 360 degrees, and then it's going to go further. We can find out how much further it goes by subtracting 360, and when we do that, we find out that it goes 50 more degrees. So it will end up being in quadrant 1. So this is 410 degrees. We have drawn our angle. And the reference angle always goes to the x-axis. It's always positive. We're trying to figure out this piece right here. Well, we know that piece is 50 degrees because we already figured out how much further it went around. And so the reference angle is 50 degrees. What's nice about this is we subtracted, and a positive coterminal angle is 50 degrees. If you wanted to take 410 and just add another 360 degrees to it, another answer that you could have written for a positive coterminal angle would be 770 degrees. Either of those answers are appropriate. A negative coterminal angle, though, is I would go to that 50 that we already got, and you would subtract 360. And so if we have negative 360, and I'll put the 50 underneath, positive and negative we subtract, and you would end up getting a negative 310 degrees for a negative coterminal angle. So all of those terminate at the same exact place. Number 12, find the missing coordinate for the point on the unit circle. So they've already given us a point here, which is negative 24 over 25. This is in our x spot. We need to find the y spot. This right here is saying negative 24 over 25. We know that 1, if we want to have it have a denominator of 25, we can change that to be 25 over 25. And we know that this y value here will also have a denominator of 25, but we need to find out the top there. So we use the Pythagorean theorem. Okay, a squared plus b squared equals c squared. We know that our a value is negative 24 squared, plus our b value we don't know, and then c value is 25 squared. Negative 24 squared is 576, plus b squared equals, and 25 squared is 625. We solve for b by subtracting 576 to both sides. We have b squared equals 49. We take the square root of both sides, and we find that b equals 7. So my y value is 7 over 25. So over here, the point is negative 24 over 25, 7 over 25. Sine is our y values, and my y value is 7 over 25. Cosine is our x values, which is negative 24 over 25. Tangent is y over x, and our y over x is going to end up being 7 over negative 24. Okay, moving on to number 13. Sketch in standard position and find the information stated here. So 3 pi over 4, again, we're going to go ahead and mark up our unit circle with having a denominator of 4. So this denominator is 4, and on top, in order to make it reduce to be 2 pi, we would double 4, and that would be 8 pi. Over here on the other side, we have 1 pi, which we would write as 4 pi over 4. In order to figure out what's here, we divide 4 by 2, and you get 2 pi over 2. And then down here we add our 2, which will make 6 pi over 2. 3 pi over 4 will end up being between 2 and 4. And so when we sketch our angle, it goes right here in quadrant 2, and that is 3 pi over 2. If we now go to our unit circle, 3 pi over 2, let's see here. Oh, not 3 pi over 2, sorry, and this was supposed to be over 4, and this was supposed to be over 4. I'm not sure what's going on with me right now. 3 pi over 4. Okay, so 3 pi over 4, here it is on our unit circle. That order pair is negative root 2 over 2, positive root 2 over 2. So we're going to write this here. Okay, this is our x and our y. And so sine is our y value, which is root 2 over 2. Cosine is our x value, which is negative root 2 over 2. Tangent is y over x, which is root 2 over negative root 2, and that reduces to be negative 1. Number 14, sketch in standard position and find the information. So this one is in degrees, so we can mark our degrees at 0 and 360. Over here is 180, halfway is 90, and then we have 270. 390 degrees is going to be more than 360. We can figure out how much more by subtracting 360, and it goes an additional 30 degrees. So for 390, we loop all the way around, and then 30 more will end up being in quadrant 1. Okay, so this is 390 degrees. It's important, though, to know what your reference angle is for looking on the unit circle. And so our reference angle at this point, we already found, was 30 degrees. Okay, on your unit circle, 30 degrees is right here, and that ordered pair at 30 degrees is root 3 over 2, 1/2. So we have root 3 over 2, 1/2. This is our x and our y. We know that sine represents our y value, which is 1/2. Cosine represents our x values, which is root 3 over 2. And tangent is y over x, so that will be 1 over root 3. You would need to rationalize the denominator by multiplying by root 3 to both the top and the bottom. When you do that, you end up with root 3 over 3 is tangent. Okay, this next one, again, same thing that we're doing, except for this time we're back to radians, and it's a negative radian. Again, you should always mark up your unit circle based on the denominator that you have. And so this time my denominator is 2. I'm going to go ahead and put 2 all the way around so I don't mess up again. And then when we double 2, we get 4 pi. Over here on the left side, we will have 2 pi. But because we're dealing with negatives, I'm going to make these both negatives, which means that we would start going down, and half of 2 is 1. So down here would be negative 1 pi. And then up on top, it would be negative 3 pi. Okay. If you just heard some noises, that was Bronson. He's sitting here with me while I'm making this recording, but he's supposed to be quiet. Okay, so negative 3 pi over 2, we start here, we're going clockwise, and we get to this point. Well, right here, we're at a quadrantal, and this point right here, we know, you could even look on your unit circle if you need to, but this point is at 0, 1 on the unit circle. So again, this is our x and our y. Sine is the y value, which is 1. Cosine is the x value, which is 0. And tangent is y over x, which is 1 over 0, but 1 over 0 is undefined or no solution. Number 16. Here, this is going back to lesson 8.9, where we are solving these in terms of radians. And so we are going to try to solve for cosine. Notice that it is cosine squared. So once we get cosine by itself, we'll need to end up taking the square root of both sides. So I'm going to start by adding 1 to both sides. We get 4 cosine squared theta equals 1. Next, to get cosine by itself, we divide by 4 to both sides. So now I have cosine squared of theta equals 1 over 4. And the last thing that I'm going to do is take the square root of both sides, and I get cosine of theta equals 1/2. Now, because I took the square root of both sides, we'd end up getting the absolute value, which means that this is going to be a positive negative. So since cosine can be positive or negative, that means that we will find an answer in all 4 quadrants, because the x value can be a positive 1/2 or a negative 1/2, and we're looking at the x values. So starting in quadrant 1, the x value is 1/2. In radians, it's at pi over 3. So one of my answers is pi over 3. In quadrant 2, x needs to be a positive or negative 1/2, and right here, this is where it's negative 1/2, and in radians, that is 2 pi over 3. In quadrant 3, x positive or negative 1/2 is right here, which is 4 pi over 3. And then lastly, in quadrant 4, x is 1/2 at 5 pi over 3. And so these 4 different radians are my answers or solutions to this problem. Number 17. So now we're solving for tangent. Also, we're still solving in radians. In order to get tangent by itself, all I'm going to do is subtract root 3 to both sides. When I do that, I get tangent of theta equals negative root 3. Now, we know that tangent is y over x. And so all you would do is put this over 1. Now, the negative can go at the top or the bottom. It doesn't necessarily mean that it has to be a negative root 3. The negative can go with the root 3 or the 1. Now, where is tangent negative? So we kind of already worked through this earlier, but tangent ends up being negative if you go through the whole process, either in quadrant 2 or quadrant 4. Okay, so that is where we're going to be looking for answers, and we're looking for the y value being root 3 and the x being 1, and one of them has to be negative. So let's go to quadrant 2, and the y has to be root 3. And so if you look here, do you see how the y is root 3 and the x is 1, and there's a negative? Okay, and so in terms of radians, that is at 2 pi over 3. Okay, in quadrant 4, we need the y to be root 3 and the x to be 1, and one of them negative. And so on this one, the x is root 3, but here the y is root 3 and the x is 1, and so that's at 5 pi over 3. And so those are my answers. Number 18, this one they've factored it for us. There are 2 different problems here, and so we're just going to break them up and solve both of these. The first one we have is 5 sine of theta equals 0. We're going to be solving for sine. We solve and get sine by itself by dividing by 5. And I end up with sine of theta equals 0. So where is sine 0? Where is y 0? And so if you look at this, hopefully you remember that y is 0 here at 0 or 2 pi, and then y is also 0 at pi. Now, because it doesn't say equal to 2 pi, the only answers are at 0 and pi. We're going to solve the other side now. So we have 2 cosine of theta minus 1 equals 0. We are solving for cosine. We do this first by adding by 1, or adding 1 to both sides. So I have 2 cosine theta equals 1. Next, I divide by 2 to both sides, and I end up with cosine of theta equals 1/2. Cosine is positive, x is positive in quadrants 1 and 4. Okay, so we're looking in quadrants 1 and quadrant 4 for where cosine, or x, is 1/2. So in quadrant 1, x is 1/2 at pi over 3. In quadrant 4, cosine or x is 1/2 at 5 pi over 3. So that's my answer. So for this problem, for number 18, there are actually 4 answers. And the 4 answers are 0, pi, pi over 3, and 5 pi over 3. Okay, number 19. This is something that we haven't really seen. We've solved these triangles, but this time it's asking us to add sine of c and cosine of c. So we need to find those and add them both together. In order to find sine of c, we need a 90-degree angle, and so we are going to bisect this, make a perpendicular line that's a 90-degree angle, which will cut this side in half and make this side 12. And so we need to find this side. Okay, we can find it using the Pythagorean theorem. A squared plus b squared equals c squared. So I have 12 squared plus b squared equals 13 squared. 144 plus b squared equals 169. Subtract 144 to both sides, and we find that b squared equals 25. In order to now solve for b, we take the square root of both sides, and we get b equals 5. So this side right here is 5. We know that sine is opposite over hypotenuse, and we know that cosine is adjacent over hypotenuse. And so when we're looking at c here, sine of c equals 5 over 13, opposite over hypotenuse. Cosine of c is 12, adjacent over hypotenuse. And then we just add them together. So 5 over 13 plus 12 over 13 equals 17 over 13. And so that is sine of c plus cosine of c. Okay, the last one that we're going to do is, or last two, is graphing. Starting with cosine, we are going to graph y equals 2 cosine of x. The only thing that we have to worry about really on this one is the amplitude, and the amplitude we know is 2. We need to only graph the first period with our 5 key points. So if we need to, we can look at our unit circle, and we know that cosine is 0, x is 0, at pi over 2, and also 3 pi over 2. Okay, so pi over 2 is in between 0 and pi, and 3 pi over 2 is really 1/2 pi, which is in between pi and 2 pi. And so I'm going to use a different color here. So our zeros for cosine are at pi over 2 and 3 pi over 2. We know that at 0, though, cosine is 1. So normally we'd have a point here at 1, but because the amplitude is 2, we go up to 2 and we make that mark. Okay, and then we have the mark here, and we know it starts up, and then at this point it's going to go down. So we're going to go down to -2 at pi. And then we have our 0 at 3 pi over 2, which means that we're going to go back up to +2 at 2 pi. Make sure that you make your function a curve, because these are curved graphs. I'm sure you can draw it better than me. And that is our cosine function, or y equals 2 cosine of x. Last one, number 21. We are going to graph a sine function. Okay, this one, it tells us we have an amplitude of 3. Okay, we also have some translating that we're going to have to worry about. And so I like to always start by marking x's at our regular parent function for sine with an amplitude of 3. So if you need to, you could go back to your graph, and we know our zeros for sine when y is 0 is at 0, 360, and 180. So in terms of radians, that's at 0, 2 pi, and pi. So I'm going to make an x at 0, pi, and 2 pi for our sine functions. Normally we would go up to 1 in between, but because our amplitude is 3, we're going to go up to 3. And then at our 3 pi over 2, we're going to go down to 3 and make an x. Some of you can translate both parts at the same time. I'm going to do it one at a time to help some of you to make sure you understand. When it's -1, we're shifting up and down, okay? And so in this case, this is going to go down 1. So each of these x's, I'm just going to make a new x because I still have to do this other translation. Each x I'm going to go down 1. Okay, so I made a new x going down 1 at each of those points. The next thing I need to do is translate pi over 2. So remember that we set this equal to 0 and it ends up becoming the opposite. So we are actually going left pi over 2. So from each of my x's, I'm going to go left pi over 2. Well, pi over 2, when you're moving, it's just one little mark. Where if we were going pi, you would end up going 2 marks. So each of these, I'm just going to go left 1 mark, which is pi over 2, and I'm going to make my point because that's actually where I'm staying. At this x, I'm going left pi over 2, making my point. I'm going left pi over 2, making my point. Left pi over 2, making my point. Left pi over 2, making my last point. And then again, remember that these are curved, and we have our sine function drawn. And that's it.